So today, the properties of logarithms is going to be the new thing that we're covering, properties of logarithms. I'm not going to do everything in this packet of notes. We're going to do some of it. Okay. These properties come from their inverse properties. Really fast, reviewing, really fast. What is x squared times x to the third?
X to the third.
Right, so what did you do to get x to the fifth? You add them. Who's them? The exponents. We added the exponents. There's something called a product property that says, I'm going to go backwards. It goes either way, but the product property says if I have a separate logarithm base b of m, and I add together log base b of n, you see if they have the same base? If they have the same base, we can combine that to one logarithm base b, and you just take m and n and multiply that. And it works the other way. However, going the other way, I don't use as often. Going the other way would be, if you have a product, you can separate to more logarithms.
Is that the sum of m, or is that the...
This is m times n, right here. Is that what you're saying? Yeah, that is, when they're next to each other, that's multiplication. So it's kind of the same rules. If we have the like bases, we're adding the exponents. Here, if I have the like bases with logs, we multiply the m and n, where it was adding. Or if it is multiplication, you add them separately. All right, quotient properties. So before I do that one, if we have something like x to the 6th over x to the 4th, you do x to the 6th minus 4, right? And you get x to the 2nd. So that is like our quotient property here that has log base b, and we're dividing m and n. You can separate that with subtraction to, and they each have to have logs. Log base b of m, subtract log base b of n. It has to be the same base. We can also go backwards. You can have subtraction, and we can combine it by putting the m over the n. And then the power property would be, kind of. I mean, the stuff with powers.
It says log base b mn equals. Confusing.
He's just reading.
So that means, do we add the bases and the logs together, and then it becomes 2?
How about I will do real examples and you'll see. I'm just going over where these properties are coming from, and then we'll do the real examples. You're not going to learn it by just me reading a property. I know that. But I do like to show you how this does compare to things we've done before. If I had x to the 2nd, and then we had the 5th over here, what would we do in this case? We would multiply our exponents, right? We would have x to the 10. What? Okay, this is, although it doesn't look like it, this is multiplication. If you have an exponent on the log, we can say this is the same thing as n multiplied by, or that exponent multiplied by the log. Okay, I'll just show you. If I have log base 5 of 7 squared,
So it'll be just 2 log to base.
it'll be 2 multiplied by log base 5 of 7. Okay, you just take this and you put it in front with multiplication. Okay?
Okay.
Those are the 3 properties we're going to practice today.
You have to take because my friends is for the picture.
Maybe, somewhere.
I see something.
Okay. get through this.
So just slowly break it apart, as you can see. It's like half. It's half.
I don't know how much of this I want to do. This is part of where I wanted to skip some stuff, but I might do like a moment of it. All right, I'm not going to do all these. I'm just going to show you a couple examples because I'm going to show you a couple of these, but this, in my opinion, is not reality anymore because we have calculators. This is how they used to do it before they had calculators with logarithms on it. Is there was this big table that said log base 2 of this or log base 2. They had like a table and you had to
Basically fine.
figure stuff out from a table. We don't do that anymore. But I do want to show you using the properties. If I have log base 2 of 3/7, I can take that and I can rewrite it if I need to. I can rewrite it as log base 2 of 3. And then what does division mean? It means to subtract log base 2 of 7. So those are equivalent expressions.
So when we just like pretend like the logs is like say it's like how we used to do like the 7x minus 3x for chapter 5, we just do it like that, so it'll be equal to like log base 2 to the -4.
We will be solving in 6-6 if that's what you're asking.
Yes.
We will be. I'll show you how to solve
So
in 6-6.
we just simplify.
Right now, we're just learning properties by manipulating stuff that's here. Like, there's no reason that I mean, I'm actually not answering the question they're asking. I'm just showing you guys with these questions the properties. Because like I said, this stuff is not stuff we would actually ever do. Because I can type this in my calculator and find the answer. Okay? But I'm showing you how the properties work. So when there's X's and you can't type it in your calculator, then you know how the properties work. Yes, Abney.
I forgot, but like, how do you get like the lowercase and then?
Okay, I will show you personally later.
Me too.
That's fine. All right, so for this one, it has log base 2 of 21, and according to the directions, I'm supposed to use 3s and 7s to split this apart. That's what the directions are talking about. Do we know how to make 21 with 3s or 7s?
Yes.
Yes.
Right, this is the same thing as log base 2 of 3 times 7, right? Well, if it's multiplication and I want separate logarithms, then I can expand, that's what the word, expand it to log base 2 of 3 plus log base 2 of 7. So the operation that is with the original combined logarithm is going to be different than the operation when you separate them. Just like if we are multiplying x to the second times x to the third, we're multiplying bases, but you actually add the exponents. You do different operations.
Wait, how would you do C by using 7 or?
C? Yeah. So,
Is it just 2 7s?
so how do I make 49 using either 3 or 7? Okay. I'm going to write it as log base 2 of 7 squared. You can write 7 times 7. I'm just not doing that. You can write it as log base 2 of 7 squared because I want to show you the quotient property. The quotient, not the quotient. What's the
Power property?
Is it called the power property? No, it's the third one. Is it power property?
Power.
Okay. Quotient is the first one, sorry. Power property that says if I've got this exponent here, I can actually move it to the front and multiply. So 2 times log base 2 of 7 is how I could rewrite that one. This one.
And then it'll be 2.
I want to make 1/3. I want to rewrite it using 3s or 7s. I don't want 1 divided by 3. I want it to be a 3 or a 7. Like this 49, I made a 7. How do I make 1/3 just be a 3?
Times 3 to the negative first.
No, times 3 will make it into 1.
But I know that's what I was like. You can't multiply because you could do that if there were 2 sides of an equation. We don't have sides. We just have this one thing.
Oh, yeah, that's
So you're
right.
not allowed to change the value of it. You're just going to change its appearance. Katie, say again what you said.
3 to the negative first.
Right, if we do 3 to the negative 1, what does that negative 1 power mean?
You can
Right, so that is 1/3. These are equivalent.
Oh.
So now where does that negative 1 go?
in front.
So negative 1 multiplied by log base 2, 3. Okay?
So
Okay.
with the proportion property, isn't it technically how we would keep changing the fractions? Like similar, but not like always.
I don't think so.
Like because like you would use multiplication
For quotient?
for the quotient. Even the
Wait. Can you go back to the log?
Not for the other one.
The power. The power?
yeah.
The last one we just did, the
Yeah.
power?
Can you go back to the...
I'm going back. The power property.
Yeah.
So what do you mean by key change left?
Oh, okay. I thought that was a question. That's why.
Okay. Well, I said it for like a half second and I was wrong. What, hon?
The first one was the quotient, and the second was
Yeah. One was quotient because that's division. The second one was product because it was multiplication. And then both of these were power.
Okay.
This one could have been multiplication. I heard some of you say, oh, that's 7 times 7. And then we could rewrite this as log base 2 of 7 plus log base 2 of 7. So we could rewrite it that way also, but I wanted to show it this way. By the way, log base 2 of 7 plus log base 2 of 7 is 2 log base 2 of 7. Right? Because we're adding 2 of them, it becomes 2 of them. Right? Martin.
How would you do like how would you do like a fraction like 2/3 or 2/5? Like that's not 1/3 because we can.
So that wouldn't work for this example that they have, so it's not there.
Okay.
Okay. I mean, we are going to do some that are just purely expand, but I just wanted to go over some with just numbers before we put X's in. Okay, I'm skipping that next section. So now we're going to expand with variables. All right. ln. Guess what ln is?
E to the x.
It is not e to the x.
Log
base.
inverses.
It's log base e. It's inverses.
Yeah.
It's log base e. So this is a logarithm. So we use logarithm rules when you see ln. It's the same thing. So what do I have going on here? We're going to expand this. We've got multiple things happening.
We make it log base division.
We're going to start with the division. And when we have division, we're going to separate to separate logs with what operation?
Subtraction.
So my first thing I'm going to write is ln 5x to the 7th subtract ln y. So when you separate those, the ln goes with both of them. We're expanding it, everybody gets an ln. Now ln y is expanded as far as I possibly can.
But you can expand.
But I can still expand ln 5x.
7 times ln 5?
No. Nope. Only because it's 7 on the 5.
No.
So I'm going to separate the 5, because it's not in parentheses. I'm going to separate the 5 and the x to the 7 first. So we're going to have ln 5 plus ln x to the 7 subtract ln y. Now, what happens to the 7?
Put it in front.
Now it goes in front of what though?
ln x.
Just the middle. They're all the yes, the middle one.
Wait, what?
It goes 7 ln x and then minus ln y. So this would be the most expanded version of that.
Will you have homework on 6.5 and 6.6?
Yes.
6.5 should be.
When do we know we got on the quiz?
When? When agreement? Sorry.
We know on that.
As soon as I can find time, I promise.
Please.
I don't get how you did that.
What part?
The 7.
Yeah.
So the 7 is a product rule that says the 7 as the exponent goes in front and multiplies.
So x is the base,
No. ln is log base e.
but it's.
It says ln of x.
I
This
mean,
is.
I think the one
So
above.
basically it's 7 log e.
You mean it's the base for the 7?
Uh-huh.
Yes. The 7 itself is an exponent on just the x. It's not an exponent for ln. ln doesn't have an exponent.
I'm just getting confused because in the last chapter we did it like the would be the base and then x would be like up in the exponent.
If it was log base 7,
But it's log base.
but I'm not trying to cancel out ln.
Would that be if
I'm
the
doing
x
something
and then-
totally different than we did before.
Okay.
So that's why it's different rules now. Avneet.
I'm confused how you got LN5 and LN X. Like,
Here,
yeah, but you just break that.
that is what operation between 5 and x squared, or x7. This is multiplication. So that's the product rule from the first page that says if they're multiplied, I'm going to separate them and add the two elements. Okay. Let's do an example. Let's do another
Keep
example.
LN.
Yes.
So you
And
always
when
got
you
ln?
expand, every term gets ln. As you expand, you're giving everybody an ln.
Oh,
Okay? When we condense, which we'll do in a moment, we get and we go back to 1. Okay? All right, here's another condense. Oh, no, this is condense, sorry. I think there's another expand. Wait, was it on that page? Did I skip it?
Yeah,
No.
it's right underneath.
It's
It's to the left.
Just condense.
one more after.
Now, what does it mean by
Like
condense?
one more.
Oh, no, I'm not there yet. I'm here. Okay, so condense is doing the opposite of what we just did. So condense is putting it back to 1 logarithm. This is, we're going to make 1 logarithm. 1 logarithm.
So it's just one log.
Okay, so we're going to condense. What does? No, let me start over. We're going to kind of go in the opposite order, which we expanded. So the first thing I'm going to look for is I'm going to look for any numbers in front that I can move to exponents. I'm going to look for numbers in front that I can move to the exponent. Okay, so my first step is going to be log 9 plus log 2 to the 3rd minus log 3. There's my first step. I just moved the exponent back up because we're condensing, we're going the opposite direction.
Okay. So,
Now, order of operations, so that's kind of like doing powers first. Order of operations, when we have addition and subtraction, we go left to right. So we have addition and subtraction, we go left to right. So as I go left to right, I'm going to do the addition first. If I'm adding, I'm going to have 1 logarithm. And what's going to happen between the 9 and the 2 to the 3rd?
Would it be 17? Because 2 to the 3rd is.
I didn't hear the operation. You guys did yell a bunch of things out, but I didn't hear the operation. If I'm adding, do I do the exact same operation to this stuff? I do something different. If I'm adding, what operation does it become? It becomes multiplication. And I'm going to go ahead and make that 8, if you don't mind.
so it'll become log 7.
Right.
Where did 3 go?
Wait.
No,
why'd
where's
you-
it?
Oh, why'd you make the 8?
Oh,
2 to 13. I just multiplied it out.
Stop talking over her. I can't hear.
I can't hear anything either.
Okay, is the 3 in the front the coefficient? The one
What
that's
3?
circled.
This one here? It's the coefficient until I moved it up and it became an exponent. It's the coefficient of the log.
I don't get what you do.
What if the 3 was like at the very beginning of it, like 3 log 9?
Then you'd move it onto the 9.
So you just like this one.
Move it onto whatever one it's in front of.
What if it's move it on the other side of the log?
I couldn't hear what you said from you.
It's like 3 and then plus log 9 and then.
So if you had like 3 plus log 9,
Yeah.
we could not combine those because they don't have the same base. This one's not a logarithm and that is. So we just couldn't combine it. We won't combine those, yeah.
That would be so like a plus sign or something separates them.
Mhm. Yep. Makes them into different terms. How did I get what? What answer? The stuff I just scribbled out in the corner? This?
Yeah.
Okay, that's not an answer. She just asked me something random and I wrote it down. But that is not
That's
any.
the answer?
I'm not done yet, no.
Oh.
Guess won't let me finish anything. Do you think after one example you're going to totally get it? No, we need to get some more examples. I'm not done yet. What does subtraction mean when we condense it?
Division.
It means divide.
So you're dividing 72.
So I'm going to write, I
Lose my mind.
don't know why it does this. I'm going to write one logarithm. I'm going to have 9 times 8. I'm going to divide, what was it? A 3.
So we
So it'll be what?
34.
Maybe. All of that is what the logarithm has. Okay? We have one logarithm now. Yeah, if this actually simplifies, we might as well simplify it. And yes, it is 24.
Where are those parentheses now?
I just drew them in so you can tell that all of that, it is log of all of that.
Okay.
So log 24 would be the most condensed that I could possibly do. Log 24.
Okay, so then that would be, when you subtract,
She raised her hand. Yes.
If it's like log base of 9, what would you do with the base? Would the base just stick with the log the whole time?
Yeah, so this is base what?
10.
Right. So it's stuck there the whole time. We just don't write down base 10.
Okay. It
It's there the whole time. It's not going to really affect anything unless, let's say it was log base 24 the whole time. Let's say the whole time it was log base 24. The whole time.
That means it would cancel.
That means at the end, we would actually have an answer, which, do you know what the answer would be?
0.
It would not be 0. It would be 1. Yeah.
Ow!
Yeah. So that's the only time I might do something past this, but I don't think there's many examples of that.
Okay. So
Make it
24
in.
is a big number. It's not. Would you say log base 10 of 24? Or would you say log of 24?
You would say log base, wait, the final answer, I'm sorry. You'd say log 24.
No of.
Log of 24. You're right. Yeah. Yeah.
okay, so when you subtract, right? It becomes division, right?
Yes.
Okay.
Okay. Hard.
So that means that log 9 plus 3 log 2 minus log 3 equals log of 24?
Yes, they are equivalent. It's just I'm changing the way it looks by using these properties we just learned. Okay? This is the one I just did.
Yeah.
Do I have it twice? What happened? Do I have it in your notes twice?
No.
Just mine? Okay. All right. I definitely need to get through these two. Definitely need to get through these two. Log base 6, 3x to the 4th. We are expanding. So the first thing we want to expand with is like multiplication division, meaning adding and subtracting when we expand it. So where do I have any multiply or divide? 3
and x.
times
X to the 4th.
x to the 4th. Very good time symbol. So I'm going to expand this to log base 6 of 3. I'm going to have log base 6 of x to the 4th, and what sign goes in between? That is addition, because if it is multiply, you add it.
Wait, log base 3 plus log base 6.
Is there anything else I can do?
No.
Yeah.
Yeah, you just put 4 in front, right?
We have this to expand out further.
And then it'll be 1 basic 3 plus 4 log.
There's no control.
Huh? Say so?
Wait.
No.
Okay.
I'm just smiling at people.
So that would be,
Smile at me. Yay.
so that would be the
Yeah, that's all I can do.
You would do
No, my directions were not combine them. My directions were expand. So I don't want to combine them. When it says condense, then I want to combine them. Okay. All right, the next one is ln 5 divided by 12x. This one has a trick to it.
It's one
Why is there always tricks in
occasion to it.
It's not like a trick. It's just you aren't going to think straight, and then you're going to make mistakes like everybody does every year.
Oh, yeah,
Well,
because
that
I
is-
got to I just started off by ln 5 minus ln 12x. And
That
then-
sounds great.
That
and
is.
then I didn't know what to do.
Then you
I'm
didn't know what to do.
talking. Like, come on. And then I didn't know what to do because the 12 is.
That's okay.
Separate
This
the
is
12.
correct to start.
Okay, great.
This is correct to start. It's the next thing that is confusing.
You separate the 12 and the
You are going to separate the 12 and the x. That's what I'm going to do next. But I'm going to go back to the beginning and look for a second. If I look at the beginning, what is actually being divided?
12.
12?
And 5.
No, they are dividing 5, but what is doing the division? It is a 12 and it is an x. Both 12 and the x are in the denominator. Both of them are division. So when I go and I separate this, there's these understood parentheses here that you don't need to write them down, but what we need to know is both 12 and x are division.
Wait, so it's not multiplication?
Well, they're multiplied together.
Oh, okay.
But when I talk about the whole fraction, both 12 and 6 or x are on the bottom. And since they're both on the bottom, they are both considered dividing. So my next step, when I expand it further, I'm going to have ln 5. I'm going to subtract ln x. ln 12. And I'm also going to subtract ln x.
Okay.
Because they're both in the denominator. Lots of people want to write a plus sign here, but that would say it was multiplied. That would say it was on top. So if you think about if it's on the bottom, it gets a subtraction sign. If it's on top,
Okay, let me just.
it would come first. It would be positive.
Let's just write that down. Okay.
Is that neat?
Is that for all the time with ln?
Or for log. It's log. It's not just ln.
Oh,
It's log. Yeah.
So if it was always on the bottom, it would always be subtracted.
Yes. So if I had like log base 4 of x over y b. I don't know. I'm making stuff up.
The log would be-
Actually, I'll put w x over y z b.
You're making things more complicated.
No. This is going to be log base 4 of w plus log base 4 of x minus
Put log base.
log base 4 of z.
You just distribute-
I'm sorry, I just forgot the y. What, hon?
You just distribute the log to all of them.
Kind of, but we need to know if it's positive or negative.
You put the log base of W for X.
negative if it's in the denominator?
Yep. And you know negative and subtraction mean the same thing.
Alright, I'm finna write
Wait,
this
why
down,
is there
cuz-
W? Oh wait, I think you
Yeah. I don't think you need to announce every time you get through.
You guys,
I just don't
But
understand that.
I know you're getting aggravated because he's yelling things out, but now you're yelling things out. So we're not going to solve a problem by doing the same thing.
Shit, I'm not.
Okay.
I have a habit.
We know. anyway, anything that's on the top is positive when I expand it out. Anything that's on the bottom becomes negative when I expand it
That
out.
W is supposed to be a 4, right? Yeah.
Oh, yeah, that's a 4. You can tell.
And then also, like, what if it was like log base 4 of ln to the something?
No,
You can't have ln in the numerator or denominator as
we're
like
not
the
going to have
L.
anything like that.
Okay, but could it?
Someday you come in and we'll do harder problems. Okay.
That's
So,
the answer.
how would, when we're condensing, if we ever condense it,
We're about to.
number 6, how would we,
That's the answer when we condense it.
or like, how would we know that ln x is not for ln 12? Like, how would we differentiate from ln?
I would go left to right.
It's actually a smart question.
I would go left to right. So I'd do like ln 5 over 12, right? And then when I combine that one, that would be like divided by x. But I can't leave a fraction inside of a fraction.
Okay.
So instead of 5 twelfths divided by x, I can take 5 twelfths multiplied by 1 over x, which is 5 over 12x.
Okay.
Oh, so like adding on to his question, would that be like ln 5 over 12 plus ln and then like over 6 or over x? You know what I'm saying?
You said ln 5 over 12 plus ln.
ln like something. Because I don't understand why you divide all of it by x.
You're not dividing the ln, you're just dividing all of that.
Yeah, I don't get that.
Because this says division, so I'm dividing whatever's there by.
Then how do you get the 5 on the top and the rest on the bottom?
How do you get the 5 on the top and the what on the bottom?
Like the 12 on the bottom.
Well, 12's already on the bottom.
Right.
If I divide by a number, I can instead multiply by its reciprocal. So since I took 5 twelfths and I divided by x, instead of dividing by x, multiply by 1 over x, the reciprocal. So that's how I was able to get it into just one fraction rather than a fraction inside of a fraction. Rachel.
How do you know which number is going to be on the numerator and which number is going to be on the denominator? Because, like,
Positives, numerator. Negatives, denominator.
Left to right.
okay, so
It doesn't even matter. If I reorder them, if I have a negative up here, negative log something, and I've got a positive over here, like this one will end up in the,
okay, yeah.
but they're not going to be that hard.
I just feel like that was a dumb question.
Okay. It's just the minus or the plus sign.
Yeah.
Okay.
It wasn't.
So condense should be quick. We condense this one, what subtraction mean? So we do log x over 9. See, 9 was the negative, so we put that on the bottom. This one. I'm looking at this. I'm going to see this 3 first. I'm going to move it up and make it an exponent. ln 3 cubed. ln 27. Okay, let's.
What was the question?
Not everybody?
What was the question for 6? What was the answer for 6? Was that it?
Yep. Listen.
Well, that was all we
Would you put them in parentheses like the 4 times?
Until I actually found the answer, I would. But. Okay, so for this, what is plus? ln, what is plus?
That's a
4
27.
and 27. They have to be multiplied together. Negative is 12, so that goes on the bottom. And then you just find this answer.
Can I see the answer to
Is it 9? ln 9?
Yes. Wait, no. Wait.
Is it 9? I think it's 9.
Yeah.
Oh, wait, is it? Wait, are we one?
Wow. If you 108 divided by 12.
Oh, so yeah, we'll be.
Oh, we already did this, so we're done with these things. We're done with these notes. I'm afraid to give you guys this worksheet. Okay. We can move on. I think we can move on. I cannot understand you.
That's not right. It's not right.
Yes, it is.
Well, 6 is the one that, the blue is the right answer. Everything else was other things we talked about.
8 divided by 12.
units, right? 12 times 8 is 108, not 118. You're adding 1 to 9, not 2. Like you carry the 1, so you do 9 times 1 plus 1. You like added the 1 and then added. All right. I'll go to the next one. The other notes are gonna build off of this. Okay. So we're just gonna use more of this.
Is it
Okay.
LN 9 or is it
It's
like
LN 9.
So we're not learning change of base.
We already learned change of base. We did. I don't know if you learned it.
What does she look like?
So what's the?
Change of base.
I can show you a different day.
Is that one like we use like thing on calculator where you make it the base in the front?
No.
When I,
We're not going to talk about it right now because it's not in your assignment.
so we already did it.
We did, but I can do it again.
Okay, you're gonna use it.
It's super easy. All right. Other notes. This one I don't know if I have up there. Let me pause my video. Huh?
Was it in 6?
6-6, yeah.
I mean, what you're talking about.
I think that would change